Hello, my name is Sweenus, and in this tutorial I'm going to show you how you can save the result of a shader to a texture asset. That is, I'm going to show you how you can download the data back from the GPU. And it also works roughly the same for buffers too. For this tutorial, the example shader is a Gaussian blur, or Gaussian, or whatever way you pronounce it. And I've also set up an actor where we pass in a texture. Then we choose our blur amount, and then we press the Run Blur button. Once it runs through, you'll then be able to see the result save in a texture asset. Note that the blur shader isn't optimized, it was made just to work. And whilst the initial setup is for it to work asynchronously, if the texture is large and requires a large number of passes to execute on the GPU, Unreal Engine will stall. There are various optimization techniques to address this that you can find throughout the internet that I won't be covering here. I won't go over setting up the shader, as you can see how that can be done with the custom shader tutorial and the permutations tutorial. And the shader code itself is pretty straightforward. Now, going through the tutorial, I'm going to follow the order of execution, which means I'm going to go from the actor to the subsystem, followed by the SceneViewExtension, and then finally back to the subsystem. Link to the GitHub repository is in the description. So starting off in the actor, in the header, there isn't too much at the top. We have some variables to customize the blur and where it saves. And then we just have the Run Blur button. As for the implementation, which is just the Run Blur function, we check to see if a source texture has been set. And if it has, we queue the texture to be blurred through the subsystem, as long as it exists, which it should be the case since it's an engine subsystem. Now moving over to the subsystem, at the top we have a t-optional with the type of fblur request data. The struct here is just a POD, a plain old data, to pass information around easier, and I'm using the t-optional here as a way to set the state if we have something set or not, rather than either strictly using a pointer or a separate boolean. And then we have our SceneViewExtension. As for the functions, we got the usual initialize and deinitialize and the getter. And the two main here are the queue blur request and the editor only function that creates the new texture asset itself. Now in the implementation, we have the initialization where we create our SceneViewExtension, and then we bind to a delegate in the SceneViewExtension. This will run when the readback is complete, and inside of this lambda, we wrap our save texture in an editor only macro block. And after that, we reset the optional class variable. So that signifies that we've used it up. The deinitialize and get functions are very basic, so I'm not going to go over those. But the queue blur request is a little bit more complicated, and what we do here is we have some error checking. These shouldn't really be an issue since the values are clamped by the UI in the actor that calls this function. And just in case there's an early exit, in case the request is already set. If not, we keep track of the current request that we've just received now, and then we queue it up in the SceneViewExtension. With that, we will return to the save texture asset later on, since that'll be the final step in the whole process. But now I'm going to move over into the SceneViewExtension. So for our SceneViewExtension, at the very top, we have our activation functor or active functor. In here, we use this to make sure that the pass only runs once, or at least until the shader is ran and we have done our readback. So then next we have our readback pointer. We'll use this to actually get the data back. We have some booleans to track the current state of the blur process, some information about the source texture and the blur, and our delegate declaration. Then for our functions, we have our queue function called by the subsystem, followed by various SceneViewExtension functions. The ones with just the curly braces are required to be implemented, but we don't actually need them. We just need the setup view and the pre-post process pass function. After that, we have our getter for the delegate, so we can output back to the subsystem, and then finally a function where we do the actual readback processing. It's just a small helper function. And then speaking of helper functions, at the very top, we just have a helper function that calculates the number of passes we need. I won't go into this specifically since this is more to do with the actual blur, and that's not what this tutorial is about. We have our constructor where we create our activator function, which basically just checks to see if we have anything queued or if we have a pending readback. If we do, we run the whole SceneViewExtension, otherwise we skip it this frame. And then the queue blur request function, we just take in the request data struct and we set all of our values from that and start off the queuing process by setting the has queued texture to true. And in the setup view in here, all I'm doing is I'm getting the texture RHI for the asset. And then we'll use that RHI later on when we go to create the buffers and that. Doing it this way means we don't have to store the uTexture to the asset pointer itself. We just take the RHI reference and work with that. Once we have that done, we move on to the main rendering setup. The first thing we do in this is we actually check to see if we're actually waiting for a readback and do that first. So if we do, we check to make sure the readback is actually valid and the sizes and all that are valid. This shouldn't happen. If you get to this point, then there is a serious error. Otherwise, we just check to see if the actual data is ready. If it's not, we just exit back out. If it is ready, we process the readback. Once that is done, we reset some values and exit. Otherwise, if we're not waiting for a readback, we make sure that the texture RHI reference is still valid. If it is, get the size of it. We use that to create our viewport, get our global shader map. Then to create our input texture, which is the texture asset, we take our RHI texture, create a render target, which creates a untracked element on the render target pool, and register that render target onto our current graph. Then we use the helper function to calculate the number of passes required, and we add the passes to the render graph in the while loop. This probably isn't the best way to do it, but it works well enough just to show you how to do the readback. In the loop itself, we have all the usual setup for the parameters, the permutation vector, and adding full screen passes. Once that loop is finished though, we create the readback and add an Enqueue copy pass. Now, if we want an immediate callback, we have to effectively flush all of the commands to be done there and then and wait until the data is ready. This can cause pretty bad hitching, so it's recommended to wait until it's ready, which is what we do at the start of this function, where we keep going through, and if it's ready or if it's not ready, we just quit and then come back in the next tick. But either way, once the GPU is ready, this will continue and we can process the readback, followed by some resetting of some values. However, if we're not doing an immediate readback, we set this to true, so the if statement at the beginning of the function runs. The last part of the SceneViewExtension is the readback processing, which gets called either at the bottom or at the top of the post-process render pass. In here, we first initialize an array to hold the data, and then we lock the readback. Doing so, we get a pointer to the start of the data back from the GPU, and we get information on how big each row is. Just a note, this might not actually be the same as your width times channels count. And by width, I mean the texture width, as there could be additional padding that you would need to take into account. But since we're dealing with 4 channels at 32 bits per channel, everything lines up perfectly. The second value on the readback lock function gives you the number of rows, which we already know the height of the texture in pixels, so that's not something we need. Next is set up some values to make retrieving the full rows easier. After that, we iterate and copy the data to our pixel data array. We release our lock and reset the readback pointer. Once that is done, we then run an async task on the game thread to pass this data back onto the bound delegate, which the subsystem is subscribed to. Now, like I mentioned earlier, I'm going to move back to the subsystem, and this is the final function in the whole process. The save texture asset from readback function takes in the pixel data and the extent of the texture itself. So first we make sure that we actually do have a blur request in process, because this shouldn't be running if there has been no blur request. And then we make sure that the pixel data itself isn't empty, because we don't want to create texture with no data. Once we can see those are all good, we first set up the asset path, set up the asset name, make sure the name is unique, create the package container, and create the actual texture asset. Once that is done, we set up the texture settings and then initiate it using the data. Now, it's also important to make sure that your format is good, as if there's any mismatch, it can create crashes and such, or you might not actually see the data properly. Then what we do after that is we update the resources, which updates the underlying resources, and finalize the asset creation. That is pretty much it. If you found this tutorial helpful, be sure to give it a like and let me know in the comments. As always, thank you for watching.